We're going to be doing graphing linear inequalities today. So what are linear inequalities? Well, if I look over here, I have some inequalities. They look like regular lines that we've graphed before, except we have a greater than or equal to sign and a less than. That's what makes them unequal. One side is greater than the other side. That's going to pose a little different way to graph them. Because when we have equals to, it means the point on the line has to equal the equation. But we're going to see something cool happen with inequalities. So let's get started. Well, how do we get started? Well, according to the snowman, we graph them just as we would y equals 2x minus 3 and y equals negative 2/3 x plus 2. All right, so I'm going to take out a nice pink pen. I like that color pink, you know that. We're going to start here with the first line. We're going to go down to negative 3 because that's our y-intercept, and then we're going to apply our slope of 2. Up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to keep this going so that I fill up the entire coordinate plane that I see. Now the next thing we would do is we would normally draw a straight line. But if we were to draw a straight line connecting everything, that means that every point we just drew the line through works in this equation. And if we do an example, let's take the easiest point here. This is the point 0, negative 3. And if we put 0 and negative 3 in here and we did the math, we would come up with a false statement. Negative 3 is less than negative 3? No, of course not. It equals. And that's why we always drew the straight line, because anything, any point on this line would work in y equals 2x minus 3. So we're not going to draw a solid line. Instead, we are going to draw a dotted line. So I'm going to go through this again, but through the wonders, I can take this now and I turned it into a dashed or dotted line, whatever you want to call it. See, this is now forming a boundary. It's breaking my coordinate plane into two sections. And the two sections are those above this line, those below this line, and those on the line or equal to. So maybe you see the next part that we're going to have to do. There's a lot of steps to graphing an inequality. My goodness. We want to show less than, where the y values are less than double the x values minus 3. Well, since we've solved for y, there's a little trick we can use. Less than. You see over here how I wrote above, on, and below? Well, where do you think less than is going to be? Right here, on the below side. So now we do what's called shading. Come over here and we shade. Notice what I'm doing. I'm taking my time to draw straight lines that go all the way to the edge of my grid. Not doing it sloppily. Takes a little time, but it's looking very neat. So what have I just done? Well, I am saying that any point in this shaded region is an answer to this equation. So I'm going to pick this point right here. This is the point 5, 0. And if I put 5, 0 in here, 5 in for x, and 0 in for y, we get a true equation. 0 is less than 7. Actually, it's a true inequality. 0 is less than 7. See, any points in this shaded area are answers to this problem, because with inequalities, there's an infinite amount of answers. Well, there's an infinite amount of answers with equalities too, but there's far more with inequalities. But anybody on this line doesn't work. So now we're going to shade the next line. We do the same thing. We started its y-intercept, which is 2, and now its slope is negative 2/3, down 2 over 3, down 2 over 3, down 2 over 3, up 2 over 3, up 2 over 3, up 2 over 3. And now you can see why I was doing the entire graph of my points. This is a greater than or equal to. So now when I draw my line for this, it can be solid because I can equal the points on the line. Whereas in the other one, I couldn't equal the points on the line. It had to only be less than them. So let's get some arrowheads on here. And now I want to shade. Because it is an inequality, I'm going to have to shade. Remember, this line divides the graph into three sections. I can be above the line, I can be below the line, or I could be on the line. According to this symbol right here, it wants me to shade in everybody who is above, because that's what greater than means, and equal to. Well, the equal to is why we made it solid. And the above, well, there's the above. So now if I were to shade this in, it would go this way. I'm going to make everything perfect by labeling which line is which. So this is y is greater than or equal to negative 2/3 x plus 2. And this was the line y, it didn't change to pink. There we go. Y is less than 2x minus 3. All right, so we've got this great big mess here. What did we prove? We're graphing linear equalities. We got these lines all over the place. We have now a solution set. Thank you, Mr. Snowman. We don't need your help anymore. So what is this big solution set? I'm going to come here. I'm going to type the letter S. I'm going to make it nice and big. And guess where the S is going to go? Right there. Right where the two cross hatches, as we call them, meet. So what did we say? We said any point in this cross-hatched area will be an answer to this system of linear inequalities. So go ahead, pick a point. I'm going to pick that point right there. That's the point 9, 9. If I put 9, 9 into each one, I would get true statement. Let's see, that's 18 minus 3, which is 15. Is 9 less than or equal to 15? Yes. Well, what about this one? Let's see, 3, 3, is 9 greater than equal to negative 6 plus 2 is negative 4. Is 9 greater than or equal to negative 4? Yes. And that's what we were trying to do. We were trying to find the solution set, those answers that work in both. All right, here's another one to try. Let's call this example number 2. Well, this one is not solved for y equals. So I'm going to take my time over here and I'm going to solve it. Okay, divide by negative 2. Y. Ah, that's right, boys and girls. Do you remember that when you divide by a negative 2, your sign of your inequality must change? So that is going to go to a greater than. And I keep going. 2 divided by negative. There is my new equation to graph. So it tells me to start at negative 1. To go up 3. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. And then I'm going to go down the other way so that I have my complete graph covered. Next would be to draw the line. So I'm going to look here and it is only greater than. So therefore my line is going to be dashed because I only want to shade in the greater than. Remember, this divides my plane, my Cartesian plane, into above the line, on the line, and below the line. And according to this, now that the sign got switched because I divided through by a negative, it wants only above the line. So I'm going to cheat a little bit here. Because I can with my smartboard. Look at that. And I'm going to fill that in. And there we go. All right, now the next line. Let me clean this up here. And the next line, oh, old Mr. Slopey Face is coming in. X is greater than or equal to negative 2. Right, this is a vertical line, remember? Oops, I still have on my shape recognition pen. Let me get a regular pen. This is going to be a vertical line. All right, so let me come over here, get a vertical line. Let's go to where x is negative 2. Okay, that's not bad right there. And it's solid because it's equal to. But hey, where, make that a little bigger so you can see it, where is it greater than negative 2? Well, greater than. Well, if I'm dividing the line in half this way, well, this is a line. Everything over here is less. Everything over here is more. And everything on the line is equal to. And this says I want equal to and greater than. All right, so I guess I'm shading. Equal means make it solid, and greater than means I'm going to go over there. All right, so I'm going to take my same little shortcut that I did over here for shading, and I'm going to do my last thing as always, and I'm going to label my lines. X is greater than or equal to -2 was this one. And this one, it doesn't matter if you put the original or you converted one on. And where is my big S going to go? Right where the two shaded areas cross. So where does the pink and the ugly yellow cross? Right there. Anybody in that section is an answer. So once again, I'm going to pick a point. There, I'm going to pick that point right there, which happens to be the point 1, 3. So put a 1 in for X, put a 3 in for Y. So 3 minus 6 is -3. Is that less than 2? Yes. Okay, now here it only wants the X value, which is 1. Is 1 greater than or equal to -2? Absolutely. Last one we're going to graph, example 3. This is an easy one. I have two y equals. So according to Mr. Slopey Face, y equals are just straight horizontal lines. Lovely. So y is less than 2. So that means I go to where 2 is. Extend my line. I'm going to make it red, and it also has to be dashed. Because, remember, I can be above the line, I can be on the line, or I could be below the line. And according to this, it only wants the y values that are below. So therefore, it has to be dashed. I can't be on it. I can't be equal to it. I'm going to shade it in again. Take my little cheater's method with a box. Now I'll label it y less than 2. All right, let's graph the next line. Y is greater than or equal to 5. Okay, here's 5, Mr. Slopey Face. It's a horizontal line again. And since this one says equal to, I can have it solid. And now they want me to go above the line. So let's take this right here and let's make this a lovely blue. And take my box. I'm going to go above the line. Hey, it kind of looks like the French flag. Y is greater than or equal to 5, and voila! Well, wait, where's my solution set? I don't see the blue and the red crossing. Guess what? The solution set is nothing. Because it's impossible for a y value to be less than 2 and at the same time that y value be greater than or equal to 5. There is no solution to this, and that's fine. We can have problems in math that don't have answers. See ya.